Okay, vocabulary review. How is estimating with compatible numbers different from estimating by rounding? Isaiah in the back, thank you.
Comparable numbers, rounds up to they both round up to compatible numbers that are divisible between factors, and rounding up is
Okay, I think you're close. I think you're mixing your definition of estimating with rounding and estimating with compatible numbers. Some of what you're saying is right. You're talking about factors. So we do want to look for factors, but it's a little different than rounding. Remember rounding, we had some strategies for rounding. Compatible numbers was something different. Does anybody have something to add to what Isaiah had to say? I know it's been a while. Anybody have something to add to what he had to say? So you were close, Isaiah. You're looking for factors or numbers that you can mentally compute easily, okay, that are close to the numbers you're working with. Does that make sense? And so hopefully as we go through these examples, you guys will start to remember doing this before. Here's the answer that the book gives. When you estimate by rounding, you round a number to the nearest unit, okay? When you use compatible numbers, you look for numbers that are easy to compute mentally, and they're close to the numbers you're working with, okay? Now, if you didn't know what that meant, hopefully we can see by working out 2 through 6. Number 2, you're trying to pick compatible numbers to calculate this mentally, okay? So I still want you to show compatible numbers, but compatible numbers that you can mentally find the answer to. Number 2, who's got a set of compatible numbers that they can replace with 49 and 8/10 and 6 and 8/10? Richard? What's that? 15 and 7? 50 and 7? So Richard's suggesting us 50 and then divide by 7. Well, does 50 divide by 7 without a remainder? Does it have any remainders? It does, right? What numbers are close that we can use that are close to these numbers that will give us something that we can mentally compute that doesn't have a remainder? I heard it over here. That's correct. I'd prefer you raise your hand though. Let's try that. Okay, Jabari. 49, what are we going to replace with 49? Okay, so instead of 50, if we switch that into 49, then we're in business. So 49 divided by 7, we'll keep that. What does that equal? Go ahead, Jabari. Equals 7. So do you guys remember doing this? Compatible numbers? And so do you guys remember the squiggly lines? That means it's about equal to. It's not exact. That's approximately equal to. So now that we've done one example, who can talk about number 3? Who wants to take a shot at number 3? Akeda. What are some compatible numbers we can use that are close to 21 and 5/100 divided by 5 and 29/100?
1, 2, and 6.
Does 22 divide by 6 without a remainder? No. Can we get some numbers that are close to these two numbers that won't give us remainders?
21 and
Akpana?
20 divided by 5.
Nice. How many of you guys got 20 divided by 5? Good. So this is about equal to 20. 21 and 5/1000 or 5/100. And if we divide that by 5, 5 is pretty close to 5 and 29/100. And what did you get when you divide that out, Akpana?
4.
Right, nice. Okay. It's going to take a few of these before you start seeing what's going on. So you missed that whole lesson, so don't worry about it. You'll start to see what we're talking about. Who can do number 4? Let me make us some more room here. So there's number 1, 2, and 3. Let's try to do number 4. Who's got number 4? Let's try number 4. Yes, Lauren. Nice. And why did you choose 24? 24 divides by 2, but can we get a number that's closer to what we have 2 and 99/100ths that's divisible, that 24 is divisible by? 4 would work, but I think we can get better than, yes, 3 is. So we do want to pick compatible numbers, but we want to pick the one that's close, the ones that are closest to the numbers we have. So you picked 2, you picked 4, and they both were compatible numbers, right? But isn't 3 really close to 2 and 9? We want to pick compatible numbers, but we also want to make sure that they're as close as possible to the numbers that we start out with, okay? So what did you get when you took 24 divided by 3? 8. Nice. Okay? Very good. Who's got number 5 for me? Can I get a volunteer? Fatima, can you try number 5? $53 with what number? 53 and 7. Is that going to give us a remainder, though? Can we get something closer that won't give us a remainder? Can we try some other numbers about that value? 53 and 7. I think you're close. Those numbers are close to what we have. Think about factors and what we have. Audrey, do you want to take a guess?
52, 32. Wait, number 5?
Uh-huh. If I give you the first one, Richard, what do you think? 54. Exactly. 54 divided by what? 9. And what did that give me back, Richard? 6. Excellent. Are we good? Who else wants to try number 6? Somebody I haven't heard from yet. Melvin, can you give number 6 a shot? Okay, if we put 19, what would you put for your second number? 10. Can you divide 19 by 10 and get no remainder? That would be 1 and 9/10, but Melvin, can I make this another number that's really close to 19? That would divide by 10 without a remainder? Yes, thank you. So I put 19 up there just to kind of see if it would get you guys thinking. And I noticed some of you guys, as soon as I put that 19 up there, you started thinking and you raised your hands. So it's not always obvious what it is, but sometimes when you play with the numbers, when you write them down, you start to see what it's going to be. What's 20 divided by 10? 2. So this is about equal to 2. Yes?
Can you choose 18?
You know, some of the other class did 18 and 9, and that worked too, because 18 divided by 9 was 2. But remember, this is just an estimate, an approximate value. It's not the exact value. If they said find or calculate, then you would find the exact value and do it the long way. But they're just wanting you to estimate. They want about close to, do you understand? Okay, any questions about this? Do you guys remember compatible numbers now? We did this with addition, where we were trying to get rid of decimal numbers by picking another number, picking numbers that were close. Do you guys remember that? It was different than rounding. Okay, let's move along. This is what we're talking about today. Back to food. Okay, can I get somebody to read for me? Somebody that I haven't heard from. Savannah, can you read for me down through to this point?
What you will learn to estimate the sum differences power and functions of fractions. New vocabulary include while and
There you go.
that are not whole numbers. On the right, 7 over 12, 1 times 1 pi, and 3 over 8 of 3 under pi lemon. You can estimate that in the total about 1 full pi lemon. A benchmark is
Convenient.
convenience under is to a few fractions less than 1. You can use the benchmark 0, 1/2, and 1 to estimate fractions.
Okay, so here's what they're saying. Sometimes they might say, hey, see this fraction? Decide if it's closer to 0, half, or 1. And we're going to use that to estimate the value. Okay, did you guys do this last year? Okay. For those of you that read ahead, that's good. That's good because when you show up to class, maybe you'll have a better understanding of what's going on. So I encourage you guys to read ahead the day before. That's wonderful. Now, take a look at 7/12. They said 7/12 is about a half. Here it is in the chart. 7/12. Well, what would be a half if I had a denominator of 12? Richard? 6/12. So this would be 6/12 to be a half, right? Well, is 7/12 closer to a half, 1, or 0? Which is it close to? And we call these our benchmarks. These are my benchmarks. So we're using these as benchmarks. And sometimes they'll use 0, a half, and 1. Sometimes they just say might be just 0 or 1. Assign a 0 or 1 to the fraction. So benchmarks. These are my benchmarks. And is 7/12 closer to a half, 1, or 0?
1.
Do you see on the number line here's a half and here's 1? Okay, which is it closer to? The half, right? So what they set up here is, hey, look, we're going to say this is about 1/2 of a pizza of a pie, okay? And then they have this other fraction, 3/8. Well, 3/8 is about here. It's close to, but it's what would be half of 8?
4.
4/8. So half of 8 would be 4/8, right? So this is less than 4/8, but it's also greater than 0, right?
Yeah.
So this would be 2/4, that would be 0/4. So 2/4, 3/8, 4/8. So it's somewhere in between these two marks here. Now, same thing we asked ourselves before, is 3/8 closer to 0 or closer to a half?
Why?
Because it's between 0 and a half, right? So we're closer to a half. So the book says, hey, look, I got 3/8. That's about a half. It's not exactly a half, but it's close to a half. And then 7/12 is close to a half. Well, what's a half plus a half? 1. So they're estimating that if they combine these two pies, it would be about a whole pie, maybe a little bit extra. Do you understand? Okay, so that's what we're doing. We're estimating using these benchmarks. If we look down here, the book explains it a little bit further. It says, hey, estimate as 0 when the numerator is small compared to the denominator. So if it's a really small number in the numerator compared to the denominator, say that that fraction is equal to a 0. Got it? Now, estimate as a half when the numerator is about equal to the denominator. So is about half the denominator. So if it's close to half, like 7 is almost half of 12, right? So 6 would be half of 12, but 7's a little bit more than half of 12, right? So we could say that's half. And if you look at this fraction over here, 7/8, what would 1 whole be if I had a fraction with 8 in the denominator? 8/8, right? 8/8 is the same as 1 whole, right? So 7/8, they're almost equal. 7 is just a little bit less than 8. So we're going to say that that's almost 1 whole. Do you guys understand how we're using these benchmarks? And this is just to get an estimate. We're not getting an exact value. Okay, any questions before I move on? Yep.
The arrows are the benchmarks?
Yeah, they're saying, hey, we're going to assign 2/9 to 0 because 2 is really small compared to 9. These are the ones they assign to half. And then 7/8 we assign to 1 because 7 is really close to 8. Okay, are we good? All right. I'm going to read this since this is the first opportunity I've had to make this video. A family, we're going to use benchmarks with fractions. A family bought a plot of land last year that was 4/9 acre. That should be a Y. They plan to buy an adjoining plot this year that's, oops, yep, in a moment. They plan to buy an adjoining plot this year that's 7/8 of an acre. Estimate the total amount of land the family will have. Well, how are we going to estimate this? They want to know the total. That keyword means what? What is that keyword?
Addition.
Addition, right? So they want you to add these and estimate how much land they would have after they bought this additional land, right? Estimate using benchmarks. Assign your fraction either 0, half, or 1. So this is the part where I need you guys to try. So the first fraction we need to look at is this fraction right here. What do you estimate that fraction to be? It's either 0, half, or 1. I'm hearing people say half. Who thinks half? Raise your hand. Who thinks 0? Who thinks 1? This is pretty close to half. What is half of 9? 4.5, right? So that's a little bit less than half, but it's close enough to half. We're going to just say half. Got it? Now, 7/8 of an acre. Class, what do you think 7/8 of an acre is? It's either 0, half, or 1. Class?
1.
Okay, I heard half. I heard 1. Who thinks half? Who thinks 1? Why did you say 1? Can somebody explain to me why they said 1? Somebody? One person? Anea.
Because 7 is like 1 point away from
It's really close to 8. They're almost equal. Yes, so we're going to say 1. So when we calculate that and we estimate the total number of acres that the family bought, if they bought that, how much would it be?
1 and 1/2.
Thank you. 1 and 1/2. Do you see how that works? How we just like do an estimate? Okay, we're not finding the exact. We're just getting an estimate, and we're using these benchmarks to get our estimate. Pretty easy? Okay, so here's what I want you to try. I want you to try and estimate the difference of these two fractions. Here we did the sum above. Now we're going to get the difference. And you guys know what the difference is? Yeah. You're going to subtract. So it's the same thing as we did before, but now we're going to subtract. Good, I'm looking around and most people are trying to do something. That's good. Is there somebody that can share with the class what they think this first fraction is? Somebody, some person, one person? Somebody I haven't heard from yet? Because I want to hear from everybody today if I can. Leonardo, estimate that fraction for me. 3/5. Do you think it's 0, half, or 1? What's it closer to? 0, half, or 1? You guys agree? Half? Okay. What about this other fraction, 1/8? Who's got that one? 1/8. Let's talk about this fraction right here, 1/8. Trinity, this fraction 1/8, what's that close to? 0, half, or 1? Very good. Okay, so if we take the difference of these two fractions, what's the difference going to be, class? A half. 1/2 minus 0 is going to be 1/2. Okay? So do you guys understand estimating using benchmarks? Okay. Now, sometimes you're not going to use half as a benchmark. For these examples, they want you to estimate the fraction to the nearest whole number. They want you to estimate the mixed number to the nearest whole number. So for the whole number part, like here, let me go ahead and read this to you. A sky surfer falls 500 feet in about 2 4/5 seconds. A skydiver wearing a wingsuit falls 500 feet in about 4 1/6 of a second. Approximately how many more seconds than the sky surfer does the skydiver take to fall 500 feet? Well, what do they want you to do? Are we adding or subtracting?
Subtract.
Very good. We're going to subtract. And they want us to estimate about how much. So using the thinking from before, but the question says they want you to estimate to the nearest whole number just before it, okay? So now instead of a half, we're going to assign our fraction what? 1 or what? 0. Or 0. So go ahead and do that. Find the difference. Rewrite the mixed number as a whole number, and then get your answer. Richard, do you have the clipboard? Is there anybody that wants to share with the class what number they chose for the first mixed number? So 2 4/5. Who can explain to the class the whole number they gave 2 4/5? Sergio, you had your hand in the back. I haven't seen you. I haven't called on you today. What do you think it's going to be? 3? How'd you come up with 3?
Fraction 4/5 was very close to 1.
So you said the fraction 4/5 is close to 1.
Yeah.
So 1 plus the whole number 2 gave you 3. So do you guys agree with Sergio? He's correct. Right, so 2 plus the fraction 4/5, he gave 1, so he gave that a value of 3. So who can walk us through the other fraction, 4 1/6? Can I get a volunteer for that one? Let me see. I don't think I've heard from Kimberly today. Kimberly? What are you going to assign 4 1/6? So 4 is going to be 4. It's already a whole number. But 1/6, we're going to give that a value. What are you going to give it? Right. So we have 4, and then the 1/6 you gave a value of 0. So 4 plus 0 is 4. And we need to take the difference. So what's the difference going to be? It's going to be 1. Did you guys get that?
Yes.
Pretty easy, right?
Wait, 4 and 1/6 is closer to 0?
Well, the 1/6 is closer to 0 than it is to half, right? Or to 1, right? So for these, they want you the nearest whole number. Okay, so 4 plus 0, 4. So this is a little bit different than estimating the fractions using benchmarks. They're saying, hey, take the fraction, decide if it's worth 1 or 0. Okay, we good? Next question. For an experiment on plant growth, did you guys ever in elementary school, I taught elementary school, so I remember doing this with my students quite a bit. Did you guys ever grew like the beans and then measured the root and the parts of it? Right. So for here, this should remind you of those experiments. I'm going to read it. For an experiment on plant growth, you recorded the height of a plant every day. On Monday, the plant was 5 1/4 inch tall. A week later, it was 10 7/8 inch tall. How many inches did the plant grow? So I want you guys to estimate. I want you to rewrite these mixed numbers as whole numbers and estimate the growth. How much growth occurred? You have to take it when you get back. Why'd you close that up?
I'll do it.
It's already signed out. Does anybody have an answer for me? Makeda, what's your answer?
10.
You're saying 10? 10 for which one? So for this first fraction, what are you saying this is going to be about?
That goes to 0.
So the 1/4 is 0. So 5 and the 4th is 0. So what's that going to be then? So this is 5 and 1/4. But you're saying 1/4 is really 0. So what can we rewrite this mixed number as? We got 5, right? That didn't change, but we changed the 4th. How much was the 4th? You said it was what?
0.
Right. And so this is really, you're saying it's going to be, oops. We're saying that the mixed number is just going to be 5.
Yeah.
Okay. Can you walk me through this other part over here, 10 7/8? What do you want to say 10 7/8 is going to be?
1.
So the 10, that's 10, but the 7/8 you want to say is going to be 1. So that means we got what? 11. Okay. So now let's estimate how much did it grow? How much?
16.
It grew, not 16.
16 inches.
If it was 5, about 5, and then later we measured to be about 11, how much did it grow?
6.
Do you understand? It was 5, and then we measured it later, got taller, it was 11. So 11 take away 5 is going to be 6. Okay, are we good?
Yeah.
Any questions at this point? Okay, now we're going to get into finding the product of mixed numbers. The strategy is the same. We want to get rid of that fraction. We want to give that fraction either a 0 or 1. But then once we do that, we want, in this case, we're not going to add or subtract. We're going to multiply. Okay? Okay, Lauren, walk us through this. What's this first fraction going to be?
For the first one, it's going to be 1 1/2.
We don't want
I mean,
any halves. It's either a whole or a 0. So 2, but what's the fraction part going to be?
it's going to be 1.
So you want to say 2/5 is closer to 1 than 0? Let's think about that.
0.
Right, because it's not more than half, it's less than half. So this is just going to be 2, right? What about this other fraction over here? Right, so 6 plus 0, so that fraction mixed number is going to be 6. So what's the product going to be?
12.
Right. So does everybody understand how we did this? Are we good?
I'm writing.
So the only thing that changes the fraction.
Well, if it's 1, you have to add it to the mixed number, the whole number, right? So in this first example, if 2/5, if that had been like 3/5, we would have said 1, so 1 plus the 2 would have given us 3 for the first mixed number. Okay? All right. So here we go. I got a few of these for you to work out. If you guys can work that out, please. What time is it? 12:15. Do we have a volunteer for the first one? Do you guys want some more time to finish this up?
Yeah.
Okay. Why don't you take some more time then? When you're done, if you could put your pencils down so I know we can continue. Okay, most of you put your pencils down. Let's try to give this a shot. Isaiah in the back, can you tell me what did you estimate this first fraction to be? So 5, 6 you said was 1, so what's the mixed number going to be then? 4. Right, very good. Do you guys agree with Isaiah? Yeah. Okay, and we're going to multiply that to this, to the number that we're going to replace this mixed number with. So 5 and 1/8, Isaiah, what would you replace 5 and 1/8 with? Very good. 5 because 1/8 is closer to 0, so 5 plus 0 is 5. So Isaiah, what did you get for your estimation then? 20. Very good. Pretty easy? Did you guys get that? Okay. Can I get another person to volunteer for the second one? Kimberly? Very good. So the first mixed number, you said 8. You guys agree? Yeah. Okay. Right. So you turned 5 and 11/12 into 6. How did you get that? 11/12 is closer to 1 than 0, so she gave that a value of 1. So 1 plus 5, the whole number, then she got 6. And what did you get for your final answer, your estimation? 48. Okay, any questions? Okay, can I get a volunteer for the last one? I haven't heard from Maya. Maya? What did you get for the first fraction? Very good, you got 7. So that means you estimated 1/3 to be 0, and 0 plus 7 is 7. And what about your second mixed number? What did you get? Is 13/16 closer to 1 whole or 0? 1. So I have 1 plus the fraction 13/16 we said was 1, so 1 plus 1 is 2. So we rewrote that mixed number as 2. Do you see how we did that? And then what do you get for your estimate? 14. Okay, are we good? Yeah. Easy stuff, right? Next thing. Now we're going to do, instead of multiplying, we're doing division. But not only are we doing division, and not only do we have to rewrite our mixed numbers, we also have to do what we did in the first opening activity. I have to find some compatible numbers. So first step, rewrite these mixed numbers, and then try to come up with some compatible numbers that are close to the numbers you get so that you can calculate the quotient, okay? You guys are doing a really good job today, by the way. Very pleased. Once you guys got in here settled, on point. Nice. Who wants to give this first one a try? Richard. Go ahead. So you said that this is going to become what? Okay, very good. So you said 43. And what about this other fraction, or the other mixed number? Okay, good. You're saying that's close to 6. All right, now, that's just the first step. Now we got to figure out some compatible numbers, right? So now this is like our warm-up. I got to figure out two numbers that are close to 43 and 6 that we can easily compute the quotient of. Well, what are those two numbers that you chose, Richard? 42 and 6. And what's 42 divided by 6? Nice. Do you see how we did that? Because we're using compatible numbers once we rewrite the fraction, like we did in the warm-up. Okay, we want to be able to mentally do this really quickly. Okay, so yeah, he was correct to get 43. He's correct to get 6. But then you say, hey, look, 43 and 6. 43 is not divisible by 6. But what's really close to these two numbers that are 42 and 6? We're just estimating. We don't need an exact. There's a time where I'll want you to find an exact. That's not this time right now. Okay, now, is there any questions about this? Because we're almost done with the lesson. Here's what you need to do next. See if you can answer these right here. Using the strategy we just discussed and Richard just helped us out with. Who would like to share with the class the first problem? Akbana, thanks for volunteering. So first of all, the first thing, we need to rewrite these mixed numbers, right? So what did you get for your first mixed number? You rewrote that, and what did you get? 36. Very good, because the 3/4 is close to 1, and 1 plus 35 gives us 36. And then we're going to divide that by this other number, 5 and 11/12. What did you get for 5 and 11/12 if we rewrote that? Very good. So 11/12 is close to 1 whole, so 1 plus 5, 6. Now, compatible numbers. The numbers are already compatible, right? So 36 divided by 6? 6. Okay, very good. Who's got this next one? Can I get a volunteer for the next one? Audrey, can you walk us through it? You look like you're going to get upset if I didn't call you, so I didn't want you to be upset. Okay. What did you get for this first mixed number? So look at 7/8. Is 7/8 closer to 1 whole, or is it closer to 0? Or think about it this way. If you had a pizza and it was cut into 8 slices, and I only had 7 left, do I have almost a whole pizza, or have I almost eaten the whole pizza? You have almost a whole pizza, so it's going to be 1. So that's one way to think about it. So if you notice, I always go back to money or I go back to food. Okay? So that's almost a whole pizza. So what can I think of this mixed number as? If this fraction is almost a whole, what can I think about this as? Right, plus this 22 is going to be what? 23. Okay, you see how we got that? Okay, so 22 plus that whole gave us 23. All right, but we got to divide that by this other mixed number. So 3 and 5, 6. Is that 5, 6 almost a whole, or is it 0? Closer to 0 or closer to a whole? Right, so I got a whole for that fraction, 5, 6, but then I already got 3 wholes. So what can I think about this mixed number as? Right, nice. Now, here's the next step. Is 23 and 4 compatible? No. Are there 2 numbers that are really close that we can use that are compatible? What numbers are they? 24 and what? 24 and 4? Right. And what does that give me if I go 24 divided by 4? Nice. Are we good? Okay. Easy, huh? All right. Savannah, can you walk me through this one? 46 and 2/5. That mixed number can be rewritten as what? 46, very good. Because 2/5 is closer to 0 than it is to 1. Nice. And what about 5 and 1/10? You're saying 5? So you're saying 1/10 is close to 0? Good. So 5. Now, is 46 and 5, are those compatible numbers? Can you get some compatible numbers that are really close to 46 and 45? Oh, I did. I'm sorry. So what's it going to be? 45 divided by 5. And what's that going to be? It's going to be what? 9. Very good. Easy stuff, right? Okay, we're almost done. What is a benchmark? Can somebody share with the class what a benchmark is? Trinity, go ahead really quickly. We got 1 minute left, so let's go. Trinity, what is it?
Is a number used to replace fractions less than 1.
Very good. Here it is. A benchmark is a convenient number used to replace a fraction. Ladies and gentlemen, please have a seat and don't move. I didn't say you're dismissed. We're almost done. Some examples of benchmarks from this lesson are 0, half, and 1. Okay, I'm just going to zip through to the end. You guys can look at the solutions here later. Now, listen, for these fractions, give it a benchmark of 0 or half or 1. What's this first one? 5/16 going to be? Every class? Good. What about 1/10? 0. Very good. 5/8? 1. 2/9? 0. Couldn't we do this one to be what? I think this one we can say a half because 4/8 isn't 4/8 a half? So 5/8 is pretty close to a half.
Please pardon the interruption. Ninth grade teachers, pick up your students in the ILC.
And last, to the nearest whole number. What's this to the nearest whole number? 1. What about this one? 11. What about this one? Whole number, but we're either a 0 or a half or a whole. What is it? 7. How about this one? 8. Very good. And that's it. You guys have a nice day. Are you done, Caden?